Good morning. In this segment today, you will see how educators and education researchers are using the Genie and US Ignite networks to deliver STEM education in innovative ways. You will hear about STEM initiatives from US Ignite and Genie in the areas of K through 12 education, in graduate and undergraduate education, and at education at the community level. Examples of initiatives at the K through 12 level are Plan IT. This is a SimCity-like game that is based on the student's own city. Students understand or learn about the impact of choices on the city they live in. Another example mentioned earlier today is the connecting of students with expensive scientific instruments located thousands of miles away. Here we see a picture of students in a school in Chattanooga viewing biological specimens under a microscope at the University of Southern California. This is a digital cinema microscope that produces vivid images of specimens. Students view these specimens using a high-resolution display and can observe and learn about the complexity and beauty of the micro-world around them. A third example, which is the highlight of this segment, is the use of virtual worlds to teach problem solving and mathematics. Students are placed in a virtual world where they have to solve problems, and in the process of solving problems, they learn mathematical concepts. You will see a demo of this very soon. At the graduate and undergraduate levels, Genie has been used with great success as a remote lab. Faculty assign experiments to students to do on Genie, and students are now able to run experiments they would not otherwise have been able to do. At the community level, there are Genie-based massive online open courses, MOOCs. These MOOCs are intended to teach lay people internet concepts related to internet policy, and there is no these lay people do not need any background in computer science or engineering. Before I get into the details of STEM initiatives at the graduate and undergraduate levels and at the community level, we will have a demonstration of the use of immersive virtual worlds to teach math and programming skills. The demonstration will be led by Leslie Asht, and other people supporting the demonstration are Mark Torpy of Lockheed Martin, Rob Chadwick of the DoD Advanced Distributed Learning Labs, and Dr. Freeman of UC Berkeley, the lead researcher on the project, who will be joining us by video. Leslie?
Thank you, Vic. It's my pleasure to tell you about the motivation and theory behind the Mars game. But first, some facts. U.S. high school dropout rates reached a historic low of 7% in 2013, but still 2 million students drop out of school every year. There are many reasons for this, but when you ask students, many of them say that they see little or no connection between what they learn in school and what they want to do and be. Since I've worked in K-12 education improvement for a couple of decades, it occurred to me that we were missing something really important, and that is we weren't engaging students in their studies. Later, when I worked at the Department of Defense, I became fascinated with the military's ability to take ordinary kids who volunteer to serve, and by determining their interests and abilities, could put them successfully on career tracks. They start where the kids are, and they give purpose to the education and training that follows. That simple idea led to the notion that most kids, poor or affluent, urban or rural, of any race or ethnicity, are playing games, and they are very engaged in their gaming. With the Mars game, we start where the kids are. My nonprofit organization, Standards Work, and Lockheed Martin's Mission Systems and Training Group submitted a joint proposal to DoD's Advanced Distributed Learning CoLab to build a digital learning game, the Mars Game prototype, that's first of all fun to play. It's immersive, but it also improves students' learning outcomes by teaching content, knowledge, and skills. Listen to our funder, Frank D. Giovanni, Director of DoD's Readiness and Training, in this video.
I'm extremely proud and happy to hear that the Mars Game is being featured at the US Ignite Genie conference. I think it says many things about the vision that particular conference has to host something like this. I mean, I will tell you, it's a great fit. The Mars Game is designed to be thin client, so it's a great way to harness the capacity of the Genie network, for one. For two, I think it's the wave of the future. If you put math into a context, into something that is not abstract, then most people find it easier to understand and to grasp. And that's what the Mars Lander does for you. It puts algebraic equations, it puts graphing into context so that it's understandable. And so that's why we really wanted to do a serious look at how do you take some of these principles from games that keep people in the gaming environment with a professional educator that really is designed, really is looking to teach young men and women a particular educational concept.
In the Mars Game, we teach concepts in math and coding to 9th and 10th graders. The learning is in the gameplay. It was developed by an interdisciplinary team of game designers, software engineers, graphic artists, learning scientists, and cognitive psychologists. Then we set out to evaluate the impact of the game through 2 studies we conducted last year. So the blue bars are the game players, and left to right, you can see the tags, I think, overall learning, then math and programming. And in the next slide, you'll see the results in engagement. Not only did students who played the Mars Game significantly outperform those students who used a conventional web-based instruction, but students told us repeatedly that they wanted to keep playing the game, and they didn't know they were learning while they played. Of interest, boys and girls learned equally. And now, for more on the technical side of the Mars Game and to see it in a live demo, my colleagues, Mark Torpy and Rob Chadwick.
Thank you, Leslie. I'm going to describe the technology behind the game first, and then we'll go to the live game. So the game is a web-based game. It's built on top of a framework called Virtual World Framework. This is a framework that was sponsored by the Office of Secretary of Defense. It's a next-generation platform aimed at building collaborative virtual spaces. So it utilizes a bunch of HTML5 kinds of technologies. It's basically designed to be a run from anywhere, from any device kind of platform. So you build your application, and then you can run it on any sort of device from any sort of location with any sort of connectivity you happen to have, as long as you have access to a modern web browser. If we can show the game on the sides here, I'll talk about, we have the game installed on Genie nodes in the area, and we're running a web browser on this laptop, and we're just pointing the web browser at those Genie nodes. So I'm going to have Rob, can we show the game on the 2 sides? So what we have here is, this is Chrome running on a laptop, pointing at a server on Genie that's running on the game. So Rob, why don't you show them around a little bit?
Okay, so I'm going to start here. We've landed on the planet. We missed the intro cinematic there. What you would have seen is our spacecraft plummeting to the Earth, and now my rover is damaged. In order to put myself back together, I have to pick up different items in the environment, and to do that, I have to write simple programs. So you can see we've got a fairly rich graphic world here. We also have a rich audio environment. There's a lot of voiceover instructing the students that we're going to mute so that I can speak to you. My first task here is going to be very simple. I access my programming interface, and I'm going to move forward one step. That one step is going to allow me to pick up my quadcopter, which is very conveniently crashed right in front of me, which gives me my overhead view. Once I have my overhead view, I can begin understanding what I need to do to navigate around this space and go pick up all the pieces of my crashed landing. We introduce additional concepts as the gameplay evolves so that students can link blocks together. You'll notice here, once I achieve this goal, I have another programming construct. I'll go ahead and turn myself around. Once I turn myself around, we're going to introduce a loop block.
So what we're doing here is we're incrementally challenging the player with slightly harder challenges, and each time they succeed, we give them more capability and a new challenge. The goal here is to get them understanding how to use programming concepts to solve problems, and do it in a way that they don't even realize that they're writing programs.
Okay, so this was successful. Mark, I now have to put together a pretty complicated program. I'm going to ask Mark to speak for a moment while I try to do that in front of you here.
So I'll talk a little bit more about the technology here. Again, this is running the web browser, and I want to stress this is all open source software. This is all available to anyone who wants to go grab it, play the game, and or extend the game. The framework itself is open source. The game engine and all the software and the content, the art, the sound, that's all open source, all available. The research that we're doing is to explore the usage of these types of games to prove that you can use games to teach domain knowledge while also making sure that it's still a game. It's still fun and players actually want to try playing it and they don't want to stop playing it, which is not traditional in a lot of the existing learning content. A lot of existing learning content really is just learning content that kind of has some scoring and maybe some graphics and sound, but it really doesn't feel like a game. Students don't feel like they want to be playing it.
So I think I've got this correct, which is good. It doesn't happen every time when we do this demo. But I'm going to successfully go and pick up my radio, which is going to allow me to download new programming and access additional game dynamics, which are going to teach us a couple new things. But let's watch as I'm rewarded with a cinematic sequence as I pick up my radio.
Yay. Now I can call home.
So I'm just going to pick this up. I'll skip past the rest of that. And you'll see we've introduced a new concept, which is my mini rover, which I need to retrieve, has moved off into the distance at a slant. Now, we skipped over a lot of the narration earlier, but you'll notice that for some reason, the way I'm damaged, I can only move left, right, up, and down. And I have to find the slope of this line so that I can follow my mini rover. My radio has allowed me to download a couple of new capabilities. In this case, the ability to draw the graph and see its slope. The students are asked to place blocks together, and we get a real-time preview of the equation that we are building. What do you think the proper slope here is, Mark?
Minus 1/2.
How did you know that?
I wrote it.
Okay, so let's do minus. And you can see as I change this in real time, I get an updated equation, but let's do minus 1/2. Excellent. So I've plotted the slope. Now what I need to do is write a program that moves me to the left and then up at negative 1/2 slope. And I think the correct solution here is going to be to turn to my left and then go forwards and forwards again. I'll go right 1. Obviously, I've memorized this. Mark, how long does it actually take the students to get through all the content that I'm doing here?
It depends. Some of them get this pretty quickly. Some of them will actually brute force try and figure it out, and they'll be all over the place, failing until they eventually get it.
Okay, so I got this one correct. Now we reintroduce the looping structure, and let's see if I can snap this together. I need to loop until I find my rover. Now this content goes on for quite some time, and we do eventually introduce some fairly complicated programming tasks, like solving sub-functions, loops within loops. There's several complicated pieces that come up as we find lines that are no longer nice, even numbered slopes. But I'm going to let the rest of this game play out while Mark tells you a little bit more about the technology that makes this all possible.
Right. So one key concept here, though, is what we're trying to do is embed an abstract concept like slope, intercept into a game, but do it in a very concrete way that basically grounds why slope is an important concept for them to understand. And by doing it in this kind of context, it gives meaning to why slope is actually something interesting that they should learn and know. So again, this is a web-based game, so that has a tremendous amount of benefits, being able to host the game on the web and deploy it on the web, update it on the web, all that sort of stuff. It's all compliant with all sorts of web technologies and infrastructure that enables you to put this anywhere and use it, right? The one thing we do need, if we go to the next chart, actually we're on the right chart, sorry, is a way to deploy it. And Genie turns out to be a perfect platform for the deployment of this type of research. So we did studies last year, and we're doing more studies this year. Last year's studies, we had subjects in Colorado, and we needed to deploy these game servers in the locations that the students were in, basically to minimize the amount of network latency. The game itself, in its current form, is a single-player experience, but when we add collaborative aspects, which Virtual World Framework provides, network latency becomes a really big issue, and the more latency you have, the worse the player experience becomes. So what Genie and US Ignite enable us to do is not only stand up as many servers as we need, where we need them, but minimize the latency that the players experience by co-locating the servers with the clients. And that's a really powerful concept that has made us very successful with the execution of our last studies and this year's studies as well. So back to you, Leslie.
Our lead researcher, Dr. Barbara Freeman, and the faculty at the school where the studies were conducted in the next video will give you some additional findings and insights.
The result was that boys from Spanish-speaking households scored the highest, significantly highest, on engagement. The other surprising thing that we found from the study is that boys and girls learned equally from the game, and the boys and girls were equally engaged with the game.
Students showed up on time, ready to go in their seats with big smiles, and were really looking forward to it.
The level of engagement in the video game was huge. It was rapt. In the control group, the students were struggling, they were looking for distractions. They were proceeding in the normal way that high school students do, which is not to say that they weren't learning. They were, but it didn't exercise great fascination for them.
Currently in a master's program called E-Learning and Technologies, and this project was brought to the table. I looked at it and I thought, this is right up my alley. It was very interesting and very fun to be a part of that and to see the difference that something like that can make, and it kind of got me even more excited about the master's that I'm going towards. So,
in the game, they actually asked a student to do something, allowed there to be a necessity, and then gave a coordinate plane. And all of a sudden, the student had so much more use for a coordinate plane and the ideas behind it, and that instilled a certain usefulness for something as simple as a coordinate plane.
That we could build such a game in open source that other people can build on and modify and distribute it on the Genie network, that has just made the Mars game all the more valuable. And now, Vic Thomas will talk about other aspects of Genie.
Thank you, Leslie. Thank you, Mark and Rob. Now back to Earth from Mars. We will talk about the use of Genie as a remote lab for graduate and undergraduate education. This has been an area of tremendous success for Genie. This graph here shows the number of students trained on Genie each semester starting the spring of 2012 to this semester, spring of 2015. Over 2,100 students have been trained using Genie by 40 different instructors. This semester alone, we have over 600 students using Genie in their coursework. Instructors assign students lab exercises to do on Genie to reinforce concepts that they are taught in class, and also to see how these concepts play out on a real network. Some of the reasons for the success are instructors no longer have to acquire and maintain expensive labs in their own institutions. Students can access Genie 24/7 from almost anywhere they have internet access. And students can now experience labs or experiments that they could not ordinarily have done. This is because they now have access to expensive and uncommon resources, such as long-range or long-haul research networks, programmable switches, wireless base stations. And since Genie is a shared community resource, the community has developed course modules for instructors to use, and there are community mailing lists for instructors and students. Moving on to STEM initiatives at the community level, Professors Thanasis Korakis and Shivendra Panwar, along with their graduate student Frida Fund of the New York University School of Engineering, have built a MOOC, or massive open online courses that run on Genie. As I said earlier, these are intended to teach lay people internet concepts and concepts related to internet policy. One of the distinguishing features of this MOOC is that it allows experimentation. This is unlike most MOOCs where you have lectures, you might do some exercises, but here you actually run experiments in addition to the exercises and lectures. And the best part of this is you do not need any programming expertise to run these experiments. Modules currently available are on internet routing and adaptive video streaming. A module on net neutrality is currently in preview and will be available very soon. So now let's hear from some educators and students who have used Genie in their classroom. Well, thank you, ladies and gentlemen. I hope this glimpse into the possibilities opened up by the Genie and US Ignite networks will inspire educators here to experiment with new and different ways of making science and technology come alive in your classrooms. Thank you.